All right, subsets that are not subspaces. It says I had to edit the grammar on this. Show that the set of matrices of this form is not a subspace of M22. All right. The easiest way to see this one is that the matrices of this form, you can't have the zero matrix. These don't contain the zero matrix. Or the zero vector, whatever you want to call it. It doesn't contain this because if, well the problem is right here. Because this contains A and 1 over A. So if A is 0, then basically if A is 0, then this is going to be undefined. And if this is 0, then A is going to be undefined. So because of A and 1 over A. So really, that's all we've got to do there. Let's look at this next one. Show that the points of this form do not form a subspace of R2. Okay, that's a typo. I don't want to get out of this so easily by saying that they're not in R2. So let's show that they don't form a subspace of R3. All right, so we've got to do vector addition. And let's check that. So we've got X. Actually, I'm not going to use X. I'm going to use A. So the first entry is A, the second one is B, and the third one is first plus second minus 2. If you remember what I said about naked non-zero numbers in the previous couple of videos back, you'll know what's about to happen here. But let's see. This is I'm going to give these subscripts. Then I'm going to do another arbitrary one with 2's for my subscripts. And if I add these guys together, my first entry is A1 plus A2. My second entry is B1 plus B2. And my third entry is A1. Well, basically, we add all this stuff together. So it winds up being A1 plus A2 plus B1 plus B2 minus 4. And we have to check to see if this is of the right form. This third thing is supposed to be the first plus the second minus 2. Well, it's the first plus the second, but minus 4. So this is not of the right form, so vector addition is not closed. And that's enough for us to say it's not a subspace. It's that 2 that messes things up. That 2 is there and it doesn't have a variable on it, which is why I say it's naked. So the naked non-zero number messes things up. Now we don't have to do scalar multiplication, but I want to do it anyway. If we look at scalar multiplication, we're going to take an arbitrary vector, A, B, A plus B minus 2, and multiply that by a constant, K. When you do that, you get AK, you get BK, and then you get AK plus BK minus 2K. So we have to look and see, is this over here, is that equal to the first plus the second minus 2? No, it's the first plus the second minus 2K. So this is not closed under scalar multiplication, and that's enough also to say this is not a subspace. And you know, I didn't think of this at the beginning, but really, if x and y are 0, we could have gotten away with this in an easier way. We could have said, if x and y are 0, that forces this last number to be -2. So therefore it does not contain the 0 vector, which in this case is 3 zeros. So that's this. We've really done 3 times the work required for this. Any one of these things, this, or this, any one of those alone is enough to say this is not a subspace of R3.